The following question was taken from the Oxford MAT 2019 paper. It is part H from question 1. Question 1 is a multiple choice section where you can score up to 40 marks. All of the questions are based on GCSE and A-level content. So reading the question, it states that the triangle ABC is right angled at B and the side lengths are positive numbers in geometric progression. It follows that tan of the angle BAC is either A, B, C, D, or E. If you would like to have a go at this question, pause the video here. Okay, so when you attempt a multiple choice question, the first thing you want to do is remove any of the non-viable solutions just by looking at them. That way you're only left with the more viable solutions, the ones that are more likely to be correct, and therefore you have a higher probability of getting the question correct. So tan of an angle, and these angles are between 0 and 180 because we're talking about a triangle, always exists apart from at 90. Now, ignoring it being 90 because it's a right angle triangle with a triangle at B, BAC must be an acute angle. We know that the solution must be a real number. And looking at these solutions, I immediately see that, well, 1 minus root 5 is negative. And so 1 minus root 5 over 2 is negative, and you've got the square root of a negative number, which doesn't exist. And so we can cross out that answer. And looking around again, you can see that this one over here, 1 minus root 3, well, root 3 is bigger than 1. And so 1 minus root 3 is negative, and so this one is not viable either. So we've already eliminated 2 of the solutions. We can now attempt the question. So we have this right angled triangle, ABC. ABC. And it's right angled at B. And the side lengths are positive numbers in a geometric progression. A geometric progression is a geometric sequence, and you should know that the first term is A, the next term is AR, and the term after that is AR squared. And because they're positive numbers, we can assume that the first number is positive, and let's take R being bigger than 1. You could do R between 0 and 1 and then do it the other way around. That will work as well. Let me just do that again. And that will work completely fine. Now, if we're taking R bigger than 1, that means as we're multiplying by R, the numbers are getting bigger. And if this is a right angled triangle where all the sides follow geometric progression, the hypotenuse must be the biggest one, AR squared. And then A can be on the side AB and BC can be AR. But there is no requirement for AB to be A and BC to be AR. It could be the other way around. So we've got 2 possibilities. And those 2 possibilities correspond to the 2 possible solutions. We now have 2 possible situations which will give us 2 different values for tan of angle BAC. Tan of angle BAC could be opposite over adjacent, which will be AR over A in triangle number 1, which will be R, or it could be opposite over adjacent in triangle number 2, which will be A over AR, which is 1 over R. And so the 2 possible solutions will correspond to R or 1 over R. Now, how do we work out R? Well, we are dealing with a right angled triangle, and there's a relationship that you learnt in secondary school to do with right angled triangles, and that's Pythagoras' theorem. And so A all squared plus AR all squared, so that's A squared plus B squared is equal to the hypotenuse squared, which is AR squared all squared, which gives me A squared plus A squared R squared is equal to A squared R to the power 4. Now what can I do here? Well, I can divide everything by A squared, and then I can solve this. Now you might say, oh, does it matter which one's A and which one's B? Well, A and B can be either A or AR, so both situations are considered in this situation. And now what I'm going to do is I'm going to simplify this to give me 1 plus r squared equals r to the power 4. And you might look at this and think, what is this? This is not a quadratic, it's a quartic. We've got a power of 4. But if I bring everything over to the other side to give me r to the power 4 minus r squared minus 1 equals 0, I'm going to say that you can write this as a quadratic. How can I write this as a quadratic? Well, if I write r to the power 4 as r squared minus r squared minus 1 equals 0, we've got a quadratic where the r squared term is being squared minus r squared minus 1 equals 0. If you don't see it, I'm just going to let z equal r squared. So if z equals r squared, we get z squared minus z minus 1 is equal to 0. And I can solve this quadratic. So I'm going to bring it over to this side. And let's solve that. I'm going to use completing the square. That's going to give me z minus a half all squared minus a quarter minus 1 equals 0, which gives me z minus a half squared equals 5 over 4. And then z minus a half squared, or z minus a half rather, is equal to plus or minus root 5 over 2. But again, we're going to decide whether or not it's plus or minus or not in a second. And that gives me z is equal to a half plus or minus root 5 over 2, which is 1 plus or minus root 5 over 2. And z was r squared, so I'm going to bring that back in. R squared is equal to 1. Now, is it going to be plus or minus? If it's negative root 5 over 2, then I've got a problem, because 1 minus root 5 over 2 is negative and I cannot square root that. So it must be 1 plus root 5 over 2. And bear that in mind, r was bigger than 1, so 1 minus root 5 over 2 would not be allowed. And so r is equal to the square root of 1 plus root 5 over 2. And so we've got r. We need to work out 1 over r, don't we? And that's going to be really messy to work out. I could do it, I could do 1 over this and it would take a long time. But let's look at my answers. So I've eliminated these two. And I've got r, and r is this one or this one. So is the answer going to be this one or this one for 1 over r? Well, r is more than 1. It can't be negative. So 1 over r can't be negative. So it can't be this one, it won't be this one. And therefore my answer must be this. So 1 over r must be root 5 minus 1 over 2 square rooted. And that's it.